Gá bhéile sa chathair de pop ar hain ceist a chathair. So we're asked to differentiate 2x squared minus 3x minus 6 from first principles. So the first thing that is useful to do is just differentiate it regularly so that we know when we differentiate from first principles, we know what we're aiming to find, we know what our answer should be. So when we differentiate 2x squared minus 3x minus 6, we're going to get 4x minus 3. So differentiation from first principles, we want to use the limit as h goes to 0. It's the f of x plus h minus the f of x all over h. So we know the f of x is just our 2x squared minus 3x minus 6. I think it's useful to find and simplify the f of x plus h first of all, and then to substitute it in, rather than do kind of everything at one time. So first of all, our f of x plus h. F of x is equal to 2x squared minus 3x minus 6. So f of x plus h, we just want to substitute in x plus h everywhere we have x. So I'm just going to multiply out the brackets and simplify. So I'm going to get 2x squared plus 4xh plus 2h squared minus 3x minus 3h and minus 6. So this is what we're going to substitute into the formula we have for differentiation from first principles. So our limit as h goes to 0, filling in what we have for the f of x plus h. And then we have minus the f of x, so it's going to be minus 2x squared plus 3x and plus 6. And everything over h. So before I go any further, I'm just going to simplify. 2x squared minus 2x squared. They're going to cancel. We have minus 3x and plus 3x, minus 6 and plus 6. So we're going to have the limit as h goes to 0. 4xh plus 2h squared minus 3h. Everything over h. Again, you could do these steps in a different way. You're still going to simplify to get the same answer. So at this stage, I'm going to cancel my h's. So divide h into the top line. I'm going to be left with this. So this is where I'm going to introduce the limit. The limit as h goes to 0, so I'm going to substitute 0 in for h. So we get 4x plus 2 multiplied by 0 minus 3, and this is going to simplify to give me 4x minus 3. So I know, because I differentiated at the start, that I have found the correct answer. On to part B. We're told that the f of x is equal to 2x over x plus 2, where x does not equal minus 2, and x is an element of the real numbers. Find the coordinates of the point where the tangent slope of the curve of the f of x is 1 over 4. So we know the slope of the tangent at any point is the f dash of x of this function. So we're going to differentiate. So our f of x is in the form of u over v. So we need to differentiate using the quotient rule. So our u is equal to 2x, v is equal to x plus 2. So du dx is equal to 2, and dv dx is equal to 1. So now substitute these back into our formula. And now I'm just going to simplify. So I'm going to be left with 4 over x plus 2 squared. Or 4 over x squared plus 4x plus 4. So we're asked to find the coordinates where the slope of the tangent is 1 over 4. So we're going to let our f dash of x be equal to 1 over 4, solve for x, and then find our corresponding y point. So multiply on the left by x squared plus 4x plus 4, and on the right by 4. Move our minus 16 onto the left. So we're going to get minus 12. And we're going to factorize x and x. Plus 6 minus 2. Again, just double checking. Plus 6x minus 2x gives us 4x, so we know we're correct. So therefore x is equal to minus 6 and x is equal to 2. So to find our corresponding y value for these 2 points, we substitute x back into our original function. So when x is equal to 2, the f of 2 is going to be equal to 2 multiplied by 2 over 2 plus 2. So we're filling it back into this function. And this is going to give us 4 over 4, which is equal to 1. So one of the points is going to be 2, 1. And then when x is equal to minus 6, the f of minus 6 is going to give us our y value. 2 by minus 6 over minus 6 plus 2 is going to give us 3. So our other point is minus 6 and 3.